Hello and welcome to our next video. This is on the states of matter. I have put what's known as a video companion for notes on my resources page. So if you wanted to print that out and add stuff in as you're copying, you can do so. Alright, so let's get started. Of course, it's not going to work right for me. Where are you? There it is. Okay. Alright, so the stuff we know already when it comes to matter, we know matter is the stuff everything is made of. It has mass and volume, and I'm hoping that you all know that when we say the term particles, we're referring to really small pieces of matter. I don't like that that's there. Okay, there. Alright. So, one type of particle is an atom, and atoms are the smallest particles that make up matter and still retain the properties of that type of matter. This picture right here is an atomic model of gold. So, according to this definition right here, an atom of gold should have the properties of gold. So, it should be like a regular metal. It should be able to shape, it should be a conductor, it should be shiny, and that should hold true. We can't really see atoms, but that's what is believed. Okay, let's go on to next, molecules. Molecule is another type of particle, and a molecule is made up of two or more atoms chemically bonded. So in this case, we have three atoms with bonds in between. This is a water molecule, and like an atom, a water molecule or any molecule is going to behave like that substance. So this one molecule of water will act like any sort of water. It will boil at 100 degrees Celsius, it'll freeze at 0 degrees Celsius, and so on and so forth. But although boiling is separating the different atoms from each other, or the molecules from each other, and freezing is making it so they stick together, and that takes us to the different states of matter. State of matter is going to depend on how the particles are moving. In every state or phase of matter, the particles that make up that matter are always moving. They just move at different speeds. So let's get started with the slowest. Oh, I'm sorry, I forgot about this page. There are 4 states of matter. We know of 3, we've probably dealt with 3 before, but there are actually 4. The differences between each state are going to depend on the speed that make up the matter, like I just said. Okay, so let's move on to solids. Okay, first thing about solids. The particles are closely packed together. There's an attractive force holding molecules together. So they're not actually bound together, those molecules, but there's a force that holds them together. Particles are always vibrating but do not slip past each other. That means that the particles in a solid are going to be vibrating in place, like it just says here. And solids have a definite shape and a definite volume. So if you think of a solid, like a book, it has a definite shape. It's rectangular, a rectangular prism if we're going to, since we're talking about something 3D, and it has a definite volume. Measure the length, the width, and the height, and you would find out what that volume is. And the same holds true for every type of solid. Rectangular, irregular, and so on. Well, not so on, just those two. All right, let's move on. There are 2 different types of solids that we're going to talk about in our class. There are actually 3, but we're only going to bother with 2. Amorphous solids are solids where their particles are arranged in no particular order, as you can see here. There's no real order, kind of like 3, and they are all grouped together, so it's not really in order. Crystalline solids, on the other hand, have particles arranged in what's known as a crystal lattice. So a crystal lattice is what we see here. And what that means is that the particles are in repeating patterns of rows. As you can see, it goes purple, green, blue, purple, green, and repeats around the shape as purple, green, purple, green. You don't have a green next to a purple horizontally. I'm sorry, you don't have a green next to a green horizontally or a purple next to a purple. Okay, let's move on. Liquids. First up, particles are in contact with each other like a solid, but they're not being held, there is an attractive force holding the molecules together, but this attractive force is not going to be as strong as a solid. Since the attractive force is not as strong as a solid, the particles are allowed to slip past each other. So they're in contact with each other, but they're always kind of moving a little bit further, faster. Liquids do have a definite volume, but are going to take the shape of their container. So we've seen this with liquids we've used in class. You pour them from a 100 milliliter beaker into a 10 milliliter graduated cylinder, and you're going to see that it looks like it's taking up more space, but in actuality, because the containers are, one container is thinner than the other, they're taking up the same volume. Yes, moving on. Ooh. Liquid particles have more kinetic energy than solids. What this means is that it has more speed. We'll get more into kinetic energy as we get into physics, but kinetic energy has to do with speed. So essentially, kinetic energy, you can just substitute in speed. Okay, moving on. Viscosity. Viscosity is a kind of vocabulary term. It means that something has an ability of a fluid to resist flowing. So something with a high viscosity is not going to flow very easily. Something with a low viscosity is going to flow very easily. Okay? So what I'd like you guys to do, here's a question. Why I put a heart, I can't explain. It's just what I put it there. I want you to name something with a high viscosity and something with a low viscosity. So something that resists flowing very much and something that does not resist flowing, that flows quite easily. High viscosity doesn't flow very easily. Low viscosity flows quite easily. Okay, moving on. Surface tension. Oh, my mistake. Okay, surface tension. The tension of the surface film of a liquid caused by the attraction of the particles in the surface layer of the bulk of the liquid, which tends to minimize surface area. It's just basically a strong force that holds the surface particles of a liquid together and make it so that it almost acts like a solid. So this surface tension allows matter that is actually denser than water to float on water, like certain insects. There's water striders and some other things. A lizard, I do believe it's referred to as the Jesus lizard. I don't know the actual scientific name. These can move on water because water has a high surface tension, not because they actually have a density less than water. Okay, double checking, great. Here we go. Guesses. First off, particles are not in contact with each other on a constant basis. They may bump into each other here and there, but they're not in contact with each other constantly. They have a lot of energy, and that energy makes it so that they're overcoming the forces that attract each molecule to each other. Particles move randomly in a straight line, so they might move, some might be moving forward, some might be moving up, might be down, but they're moving in random directions but still staying in a straight line, not curving. And a particle in a gas is going to keep moving until it hits another particle or it hits the side of the container. And because of that, they have no definite shape or volume. So they take the shape of whatever container they're in and they're going to take up the volume of whatever space is given to them. All right, let's move on. Plasma, the fourth state of matter. It's kind of like a superheated gas, or it's matter with positive and negatively charged particles. So if you superheat a substance, it becomes plasma, and this is very high temperatures, ones we typically don't see on Earth because they're mostly found in stars. But we do see it on Earth. I'll get to that in a second. Speed of particles in a plasma is so fast that the particles collide and the electrons that are on the outside of these particles, these atoms, get knocked off. And because of that, it becomes a positive charged particle and there's negative electrons moving around by themselves. Plasma actually is the most common form of matter in the universe. Not necessarily on Earth, but definitely in the universe. And that's because it's found in every star, and there's a ridiculous amount of stars there. Other things it's found in: lightning, neon gas, and fluorescent light tubes. And neon gas lights and fluorescent light tubes are very similar. Okay, moving on. Here are a couple of pictures, so you can see the gas particles, not very close to each other, moving around, not taking up the entire container. Liquid particles, they move close to each other, not as far apart as gas. They're moving faster than a solid. This isn't a great depiction of any of these because none of them are showing that they're moving. But as I said earlier, it's always particles are always in motion when we have matter. And then this is a pretty cool picture of what plasma can do. So if you've ever seen one of these where you put your finger on it and it zaps towards it but doesn't really shock you, that is plasma that's making that happen. Okay? All right, so make sure you answer the questions and we'll be going over them tomorrow, and I will see you then. Good luck. Bye.